So good morning, everybody. My name is Sylwia Kopczyńska, and today I have the honor to welcome you to the lecture, the open lecture that is realized within the program of Akademicki Poznań that is sponsored by our city. And the lecture would be given by Professor Tony Gorschek. And now I would like to ask our Dean, Szymon Wilk, to introduce our speaker.
So thank you very much. It is my pleasure to welcome all of you at another lecture within this Academic Poznań program, and also to welcome our speaker. And let me briefly introduce you. So Dr. Gorschek is a professor of software engineering at the Software Engineering Research Lab at the Blekinge Institute of Technology in Sweden, and a senior researcher at Fortis, Germany. He has over 10 years of industrial experience as a CTO, senior executive consultant and engineer, but also as chief architect and product manager. In addition, he has built 6 startups. His research interests include empirical software engineering, applied AI in software engineering, which includes AI for software engineering and software engineering for AI, technology and product management, and value-based lean development of software-intensive products and services. So, once again, I would like to welcome you, and, well, the floor is yours now. Oh, or should you? So, yeah, so please.
Thank you very much. Hello, everybody. Thanks for coming. I'm hoping I'm not going to bore you too much today. Since it's recorded, I need to have this, right? In my hand? Okay, this is going to be new. 2 things to keep control of. Let's see if I can click the correct thing. Thank you very much for the kind invite and the nice presentation. I've done a lot. I'm getting old, I think. But today I'm going to talk about mainly requirements engineering. How many of you are in requirements engineering? Oh, a couple. Good. But it's relevant for all engineering, right? So requirements engineering is just one main process area of software engineering, which means you can apply this to most main process areas of software engineering. And I'm not a hype guru. You know, I don't jump on every hype train and say it's the best thing and then the next comes. I don't do that. I'm an engineer. I see everything as tools, right? But Gen AI and AI is the first time I actually see it as beyond a tool. And that both scares me and makes me really excited as a nerd, right? So it depends on how you look at it. But I won't go... oh, it's the wrong one. Genius. See? 2 things, doesn't work. It's on. It's on, okay. It's not my fault. Just bad requirement. No, I'm kidding. No. It works. Good. Thank you. So an actual engineer here. Good. About me, I worked in industry as much as I worked in academia. Probably it's outdated. I'm probably more academic today. But I generally, my philosophy is this. I try to do relevant work for industry and with industry. And if industry thinks I'm an academic and academics thinks I'm a consultant, then I'm succeeding. Sadly, what I'm doing lately is leading research groups and leading projects rather than doing work. So I try to do work. But with the advent of Gen AI, I actually started nerding myself into the tech again, which I really like. However, you also see limitations, right? It's one thing to see a YouTube video and talk to the companies. It's another thing to actually see it in operation. So what do I work with? Well, I mainly work with companies, and I work at Searle, Sweden, so Software Engineering Research Lab. We are very small, but we are very focused, and I would say our claim to fame is close industrial collaboration. So a significant part of our funding comes directly from industry, and all of our projects are with company partners. The good thing about that is we see application immediately. So, right, so we get the problem from industry, we try to figure out if it's a cause or a symptom, and then we try to work on the cause, and then we try to transfer that solution potential to industry, and we work with industry to design the solution. And many times industry doesn't really know it's us who does it, which is good. Then we measure the effect and publish. So that's generally how we try to work. And we have a lot of different areas. But I would say the overarching theme last couple of years has been Gen AI and the impact or non-impact of Gen AI on engineering and vice versa. But before we kind of get started on AI, it's a really big term, right? AI research is larger. It's like software engineering is like, it's the coffee money of AI, right? It's a huge research field. And I'm not an AI expert in any way. I'm not an AI researcher. I'm an applied engineer, and I like tools and I like technology. But here's a very hard characterization. But in general, we've been working with machine learning and machine learning applications for a very long time, and it's really important, and it's still really important. But it's specialized. You need clean data, you need to train the models, you need to actually have very specialized tasks. So an example is a self-driving car, object or recognition, right? Those are critical fields, and they are going to be needed now and forever. So nothing to take away from that, but that area is already huge and really well populated and well researched, and it needs more, but that's basically it. That's not really what I'm talking about. Even if this can be used in products, what I'm generally talking about is Gen AI, right? So LLMs, generative AI, agents, right? But different layers, those are different layers. But in essence, it opens up a completely new way of applying AI, if you will, for non-experts. So you don't need to be a data scientist and or a machine learning expert to be able to apply Gen AI to tech and or to practices and principles doing engineering. That's the point. You also can do it as a normal user at home, writing a poem or writing your homework, right? But that's kind of a deal breaker and a deal changer just in a couple of years. We didn't have anything close to this. And when 3.5 came, you remember? I was like, eh. But I think, if the tech curve increases, this is going to be big. And I had two camps of friends, right, in research and industry. One camp, and here's the interesting thing, I'll let you guess. One camp was super negative. This is completely meaningless, it hallucinates, it's dangerous, it's stupid, it just burns electricity, there's no point, right? That's one camp. And I can do better, I can code better. Look how I fooled it, right? That kind of group. The other group was like evangelists. Oh, it's the best thing ever. Oh God, it's going to change everything, right? It's the new, thing. Guess which scientists belong to the negative group? Machine learning experts or not? Yes. That's so interesting, right? I would think that the machine learning people were the first one to jump on the Gen AI train, right? No. They were like, no, this is stupid. Don't do this. And I'm like, okay. I'm not that religious in these circumstances. I see benefits on both. This is core and performance-wise and quality-wise. You cannot compare the two, but that's not the point. The point is that Gen AI opens up different application areas, which we need to really take care of and really think about. And that's my talk today. Make sense? Oh, and I'm not offering all the solutions here and telling you what to do, because it needs research, like 20 years of research. So I'm just proposing some ideas, having some postulations, and then you can judge if it's the right ones. And if I have some good ideas, maybe. But I've tried to be a little predictive too, so you can record, this is recorded forever now, and then in 5 years, people can point at it and say you were completely wrong, and I'm okay, that's fine. So who cares about the hype? Well, I see Gen AI, right? I'll use AI and Gen AI interchangeably, but I'm talking about Gen AI. I see it as impacting two fundamental different perspectives, and more, but I kind of try to divide it into two. One is AI for engineering. So basically, if I use Gen AI when I code or when I do requirements or whatever I do, literally it changes the way I work, right? So think about it like you can think about it like a tool, auto-completion tool for coding, absolutely, right? But it goes beyond that. It actually writes the code for you when you give it several language, so you literally give it natural language, it can write your code for you. that is kind of autocomplete, right? But on steroids, 5 levels more. But what's the difference between assembly versus Java? That's also quite a large gap, right? So you can see it like that, like a tool. But you can also see it as a collaborator, right? I generally see it as a genius collaborator with the memory of a goldfish. Because genius, well, it depends on how you define it, right? But to be honest, if you combine a really good frontier model with good prompting, it outperforms me in coding. I'm not saying I'm a good coder, I'm not a bad coder either. There's probably humans who are better coders than any AI, right? But the average coder isn't better, has longer memory, is a human, has a brain that stores stuff for a long time, contextual awareness, but in pure coding, sorry, that train is gone. So the question is, well, no, then we can't use it. Well, it's going to be used. Doesn't matter what you think. Why? Because there's money in it. And there's production in it. It is what it is. Now, how can we use it? Well, as engineer, I see it as if I'm using something, Gen AI, it changes how I do the work. So we need new engineering principles and practices and training. So when I trained a software engineer in the university before, you know, take your master's degree or whatever in software engineering, 5 years ago, tomorrow needs to be different because they have a completely different capacity and they do different tasks. And we have barely scratched the surface on this. And if we want to stay relevant as researchers and or teachers and or universities, we need to really find the new niche, the new focus. So I'm sad to say that everybody who has their traditional courses, you know, you've been teaching that for a long time. I mean, some courses might be stable like math, but even math is dangerously close to, I teach my 10-year-old mathematics, right? But I teach him mathematics on a different level. Not before I sat down with him for hours going through stuff, right? Today I sit down and then I have a pre-prompted AI which basically asks him questions and he has a conversation with the AI, and the AI is eternally patient, never loses his temper, never has other things to do, right? The trade-off is sometimes it's wrong. Yeah? Sometimes. But most of the time it's not that wrong. And then I also, of course, quality assure. But this is different, right? So all fields are different because the engineering practices change. The other perspective, which is actually even more important but few people talk about, is basically what happens when Gen AI is in the product, right? So you have a self-driving car, you have whatever product it is, and you have a Gen AI component that's creative. Well, it can be created by, it can be as simple as a chatbot, right? So instead of having a static chatbot that's trained on customer data, which is cleaned and fixed and it has pre-prompted answers, and it's literally if-then, right? It's literally generative. Well, most chatbot companies who've been very successful or outcompeted when 4 was released. So I think that one of the fundamental problems here is that if you include Gen AI and not machine learning, because machine learning is deterministic, you can predict the answer, at least the span of the answer. But Gen AI is per definition acting as a non-deterministic component. Well, that changes how we architect, how we require, etc. And that requires new research, new theory, not only new application, but new theory and new knowledge which feeds into AI for engineering. And these two together are really important, and this completely changes my field of software engineering. And that's kind of the focus. So I have these two focuses, and I basically have the same for AI, for requirements engineering, and requirements engineering for AI. It's the same principle, right? But it applies for all engineering, really. And I put this disclaimer there because I don't want to people thinking I'm an expert telling you what to do. I don't know. I only can observe what's happening in industry. And I would say official numbers from companies like, I can't say the name of the company, but think about this big telecom provider in Sweden. No, I'm kidding. Exactly, it's completely, no. Jokes aside, Ericsson is really good at, I'm taking Ericsson as an example, right? They're not good or bad. I'm just saying them as an example because they are really on it. They started with applying Gen AI a very long time ago when it was young, and they really saw the potential. So they actually are working more AI native now than most companies. And they're, I would say, in the telecom business, they're leading, and I would say in Sweden, they're much in the leadership in terms of applying it in a smart way. And when doing that, of course, you make mistakes and redo, right, and improve. But I would say 30 maybe % of the code. And think about that. That's a lot of money and a lot of code, right? And quality assured, as good as normal code, even if not better. So that's just the beginning. But the interesting thing is that that's the people I interact with, because they actually use it and see what works and doesn't work. And that's kind of where I try to be. So if we start with the first part, and that's AI for RE, right? So Gen AI as a coworker, and how do we do the profession, right? So if we think about requirements engineering, we can replace it with coding. It's the same principle, really. And that is, well, there's a couple of things we're already doing. So for example, you can actually use Gen AI to elicit information. You can take a competitor system and you can task Gen AI to actually elicit requirements from that system and functionality. You can attach a graphical user interface adapter so it can actually scan and try out systems, web systems or normal systems. And it can actually extract functionality and good ideas. How many times do you develop a system which is brand new and nobody ever developed before? Very seldom, right? Which means most things you're doing at least is part of some system somewhere. But what you can also do is you can parse huge amounts of requirements. You can at least create interview and questionnaires for users, if not actually getting the Gen AI to ask questions directly and analyze the questions. Now, when I say this, the fundamental problem is this. The second something spins up and it does it really fast, right? You end up in a situation, how do you know it's true? Yeah? So if I tell an AI, create 100 requirements on this, and blah, done. Is it good or bad? The problem is it does it so fast, and it looks really good, right? Might be good or bad. But then let's ask the other question. Let's say you have 20 people who do the work, right? And they go away for a week, and 100 requirements, come back. How do you know that's good? I mean, people make a lot of mistakes too, right? So I try not to judge AI too hard, right? By saying, oh, it needs to be perfect or it's not good. No, it needs to be better than average people. That's it. That's my quality criteria. Because I work with average people, on average, because it's an average. It can do classification really well. It can actually work really well from goal to requirement transitions. And this is something I really like. One of my pet peeves with requirements engineers, which I don't like, and people are fighting me on this, many requirements engineers don't like me, which is fine. They consider me a non-requirements engineer. And then other people look at me and say, I know you're a requirements engineer, it's perfect. I like goals. I don't like to tell developers I want a green button. I want to tell developers, start the freaking machine. The developer is not stupid, right? And the developer knows you need a button. And if the developer doesn't know you need a button, right? It might invent something better. And let's say it doesn't, there's no button, and I can't start the machine, I'll tell the engineer, add a button. But if I focus on adding buttons all the time in my requirements, I'm going to get what I ask for, and I might be not the smartest person in the room. And 500 engineers together might be smarter than I am. So I like goals. What I mean by that is I like giving a person a goal. We should achieve this, right? And then they have the freedom to actually figure it out. It's called actually lean and agile. This is literally how you should work if you're working in an agile organization. And you divide. The nice thing about AI, you can do it fairly fast. You can divide metrics and GQM and goals, and then you can connect it to functional requirements, and you can automate this process fairly well. You can say, how do you know it's true? Well, if I have a conversation with Gen AI and it creates 50 goals, 1,000 metrics, 5,000 requirements, let's say, I'm just inventing, right? That's a lot of work for humans, yes? I can spend the time I would have spent on writing those requirements by reviewing them instead. So what's the problem? It's wrong, yeah, like everybody. Of course it's wrong. Some are not needed, some is stupid, fine. But it's still, the capacity is there. Formalization is really nice. You can go from natural language to formal specifications, where I actually started, which nobody really uses in industry because it's too expensive, and also it's only as good as the person knowing the formalities, the formalism, which means that you end up in a situation where a person who's really good at the specification fools a person who's not, which is a bad idea. But with the translator, you can actually get it really well now. So you can actually start using formalization in requirements engineering, which is a good thing. It just doesn't scale, but now it might. So it opens up new research windows. If I was in formal languages, I would jump at Gen AI because it gives an interface to reality and normal people. Not that, well, they're not normal. Formal people are not normal. Traceability, also a pet peeve, right? We want traceability. Yeah, have you ever had a specification over a couple of hundred requirements and try to connect everything that depends on everything and it becomes super spaghetti? And then somebody forgets a link, yes? And then you don't know what's linked and not linked, and you can't trust it, and you wasted all your time on connecting stuff. That's the normal procedure, so you don't link. Or you link it by talking to people and knowing, right, or grouping. AI is really good at this, and it's cheap in doing it. And then, of course, modeling, right? You can literally take natural language to requirements, right? Formalize the requirements or not, and then you can actually create diagrams, etc., and different abstraction representation. So this is quite powerful. We can already do this fairly well. Let's take an example of this, something I worked on. So if we no longer have to focus on the how, right? But we can actually, we don't have to write the functional specifications ourselves, but we can focus more on the why, right? So Gen AI takes care of the actual specification. I'm provoking you a little. This is not how it should be, and it doesn't work 100%. But it works kind of. And if we take a logistics system as an example, you want to optimize fuel consumption, track delivery, secure delivery, speed of delivery, that kind of thing, right? So think Uber, think transports. Well, the human role might be using GQM to actually give goals, right? And one goal could be, for example, maximize delivery efficiency while maintaining 100% safety protocol compliance. Then the human sets the boundary. What is efficiency, right? So you define the actual big stuff. What's efficiency? What does that mean? Is it should always be delivered on time? Is it fuel economy? What is it? What's the most important thing? And which are the most important goals? That's the human space. And then the AI generates 200, 300, 400 requirements based on this priority. So it operationalizes what the human says, but the humans work on goal and purpose level, while the AI works on detail level. And then, of course, there's a matching and a review process. But this is a way I'm working with, and I think this is a really good way of thinking about it. So I don't tell the AI, tell me what to build and why it's important. I tell the AI what's important and what to build, and the AI builds it. We have requirements in this case. Another one is same example. Well, I ask the human focuses on how does the system prioritize high priority medical delivery, for example, versus energy savings, right? So you want the kidney delivered on time, but you also want to optimize fuel efficiency, right? Now, how do you prioritize this? And AI can't tell you that. They don't know, but we should. So we are forced to actually focus on the hard questions very initially, instead of focusing on there's a green button, which is completely irrelevant for the system, really, if you think about it. Then you create metrics. So, for example, percentage of life critical tagged with deliveries arriving in a certain time. And you use this as input for the AI that then goes and does drafts requirements and also creates a verification validation agent to make sure that it tests the requirements so that you're actually compliant with the goals you achieve. And this is kind of another interesting thing and another different interesting way you can actually work. But you can translate this to code, really. It's the same principle. So you have high-level abstraction and high-level goals, what you want to achieve. You have boundaries you set up, which are goal-based. And then the actual Gen AI part creates the artifacts that you need to operationalize what you're doing. And I think that's a nice way of thinking about things. But here, initially, this is more AI as a generator. But if you set boundaries for it and give it more autonomy, it's more Gen AI as a co-worker. And the problem with that is it creates some challenges, of course. But if we are basically doing an honest reality check on what I just went over, there's some studies showing that 19 to 4%, depending on how hard you look at the numbers, actually failed by being more productive in relation to using Gen AI. Everybody thinks, yeah, I start using Gen AI, I'm more productive. Actual figures show, early figures show that you get less productive. And then you think, oh yeah, Gen AI is not good. No, a couple of things you need to take into consideration. First of all, you're learning a new way of working. We don't train engineers to work in this way, right? So you're a traditional engineer like me and everybody, and you're applying a new way of working, which is not only a tool, but a completely new way of thinking and working. Of course, there's a learning curve and an investment. And you're burning too many tokens, and you're doing stupid stuff, and firing off huge context windows 24/7 to large companies who say, thank you, thank you, Bill, thank you, Bill, right? You don't do that. So one, you need to learn how to use it efficiently and effectively, and that's the training part, right? Another thing is garbage in is still garbage out. So if you tell the AI stupid stuff, it will create stupid stuff. You can tell the AI good stuff and it still can create stupid stuff. Or it creates stuff that's better than you thought, or it creates a combination of thereof, or it creates complete errors, but it's so secure in itself, it looks really good. Have you ever met a proper salesman? Here's how you know you met a proper salesman. Whatever they're selling, you want to buy it even if you don't need it. Look at my car salesman. He's a proper salesman. He doesn't sell anything either. He just gives me a cup of coffee and talks about my life. And then I say, what about the rims? Yeah, we'll handle that later. And then I go out there and I'm really poor. That's a proper salesman. My point being, Gen AI is a really proper salesman. What's the revenue model for Gen AI? Use, yes? Does it want you to get perfect answers the first time? No. You saw the leak by Anthropic, right? How they use their models internally and how they actually get you to use their models, for example. It's quite interesting. Listen, they want you to use their stuff. You pay for use, yes? Of course they want you to use it as much as possible. Maybe not the best idea to use it for everything all the time because it's expensive. And it should be because it's actually a golden resource. It can do good, cool stuff. And also, it generates a lot of stuff because the actual systems, not the LLMs themselves necessarily, but the actual systems are designed to encourage use and iteration. Which means you can need to be smarter in how you ask the questions to get the right answers in fewer iterations. But that's like coding. You can code and you can create 100 lines or 5 lines, yes? No difference. It's just natural language, which makes it trickier and easier, depending on how you look at it. So adoption is near universal, right? I didn't think I would say this. Just a year ago, I said, no, few are adopting it, but I think that ship has sailed. I think everybody's looking at adoption. They're in some companies, not the companies I work with, because I won't allow that. But in some companies, they actually measure token use as a good thing. And I'm like, what? That's like measuring electricity. The more you use, the better it is in the sauna? No. The heat of the sauna should be good with as little electricity as possible, right? So you want as good results as possible with as little token usage as possible, yes? But they don't know because it's not the actual engineers deciding, it's managers, and they have no clue. We need to use it a lot, so if we get big bills, it's used a lot. I'm like, okay, good luck with that. it's still pointing towards that it's going to be used, and it is used currently. Is it going to be used as it is now in 5 years? Of course not. It's going to be used as much, maybe more, maybe less. Maybe it's going to be local models and enterprise models divided, right? That's how I work. I have a bunch of local stuff I run, and then I only pipe it to actual enterprise models when it's needed. And I think that's the future, to be honest. So you'll be running on local stuff more or less for free, except electricity and initial investments. But given token cost, that's paid off fairly fast. But what we do measure is that we have measured value is very variable and very dependent on how you use GenAI, not if GenAI is good or bad. And that's like any tool, really. You can use a hammer to screw in a screw, not optimal. And I would say, I kind of like this curve. And I actually had AI draw it for me, so I can't change it, so it's not perfect, but you get the gist. Basically, I look at transformer models and LLMs like this, and I actually think we're kind of here. The context windows are too expensive to expand. There's limitations in the basic technology. We don't have much more data to train it on. New models are generally trained on the same data now, plus some AI-generated data, which some papers say it actually creates worse models, which I actually think it's kind of logical because everything kind of collapses. Which means that, but if we assume we're at peak, right, we don't have to, of course there's some improvement, but let's assume models don't change at all. It freezes today, done, okay? Actual utilization in society, I'm mainly talking about engineering and engineering companies first, but then society as a whole, so a nurse working in a hospital, I'm talking about a person planning the routes, I'm talking about a carpenter using it to auto-bill because he is doing carpentry and doesn't have time to sit with, you know, economy stuff and sending out bills, so that he doesn't and he loses money kind of thing. That kind of adoption, I think we're at a couple of percent max, which means that our work, in my view, our work is at least 20 years in front of us, working very hard to figure out how do we make this work properly, even if models freeze, and they won't. And also, there's come something after the current type of technology. I don't think it's that easy, because transformers and the current models have been around for a very long time. Electricity, data, and processing power is basically the game changer for GenAI. And I don't think there's like 500 stacks of new stuff coming. There's going to come something new. But even if it doesn't, it's like machine learning, right? Machine learning is, I don't want to insult any machine learning people, but it's not like it's a completely different concept 10 years ago and now. It's, you know, you tweak and refine, but it's still the same principle concept. Same for GenAI. So I think GenAI is going to be part of our lives for the future, which means we need to adapt and figure out how the engineering works. There's a validation paradox also, which is really important with GenAI. So if you have a 1000x productivity, right? So instead of me writing one use case, right, I get the GenAI to write 100 use cases in like, I don't know, 20 seconds, 10 seconds, 5 seconds. The fundamental problem is that even if GenAI generation, and even if it's reasonably good, human validation is the new bottleneck. Before it was actually talking to people, actually writing the requirements, right? Then you barely had any time to validate them. But you had built-in validation. You and me are talking about the requirement, right? And I write it, but we're talking about it. So I'm refining, improving, and writing at the same time. It's not, you know, talk, write, validate. No, it's continuously, right? Because we're humans. AI doesn't do that. You prompt it and have a conversation. If you're smart about it, you don't just tell it, but you have a conversation about it. And the AI asks you questions, you answer, and then it generates something. But what it generates, it's generated. It's not taken from you. It's literally statistically generated based on the prompting you did to increase statistical significance of getting a specific word and or a specific sentence, and that's a context. Which means that validation is really important. The problem is we don't have 1,000 humans all of a sudden. We only have one requirements engineer, or 5. And all of a sudden, one thing is automated, but then you need to quality assure it. And basically the human role in this is 4 things. Intent, the why, right? And that's basically goals. Boundaries, setting the boundaries of what it should be and not, what's acceptable, and is it coherent? And I think coherent is really important. Gen AI might really do a really good job on a module, but it sucks at connecting the dots long term to figure out, does it work together? Architecture of some sort. Architectural requirements, architecture of a system, doesn't really matter. And that's where humans need to shine. But in order for you not to have to review everything in detail, you also need to set boundaries and clear rules for the AI to work within. And even then, it's going to have a problem by hallucinating and or generating stuff you don't want to. One of the largest problems you have with Gen AI, especially in coding, is not necessarily that it generates bad code. It is that it generates code you didn't ask for. And what's the implication of this? Let's say you have say you have a huge system, right? And say you have 25,000 test cases, you run regression overnight, right? Every build, yeah? Well, it passes all of them. Great. Done. Oh, but it added a small green apple in the bottom corner. If you click that, you have admin privileges. Why? Because it needed a shortcut to test something out and forget to remove it. And not in your test cases. Oops. Get it? That's really dangerous, right? And also when it implements stuff in a way you didn't think of, which might be better than you thought of, or it might be really bad. But it still might pass the test case. Then you say, why don't you have AI checking AI? Absolutely. That's a road. That's a research avenue. But then you need an AI checking the AI who checks the AI. Then you need, yeah, you get it. So I would say AI drafts, humans quality control, and decide what counts and what's important. I think that's the key takeaway. You can absolutely improve performance. So instead of me writing 10 use cases, the AI does it and I review them. Reviewing them is much faster than actually writing them. But it's also a different skill. Reviewing stuff is really hard if it looks good. It's really easy if it's badly done, but if it looks good, it's really hard to catch errors. And that's a new type of skill. The question is, that's something we need to teach students and engineers. If you're not doing anymore, but you're actually quality assuring, you need to do. You need to know how to do and how to quality assure. But then the paradox comes, well, if we let students use Gen AI to code, which they have to do, because otherwise in industry they can't code, how do they learn how to code? And this I don't know the answer to. That's the thing that scares me the most. It is human degradation. And you can argue this has already happened with the calculator, with car, it doesn't matter what it is, right? Yes, but this is intellectual degradation. Not counting, but mathematical degradation. And that's a different thing. Because humans thrive on actually painfully exploring the problem space and failing. And you learn while you fail and while you, right? When you're working with it and it doesn't work and you're like, what the hell? Maybe it's just me, but that's how I work. Like 90% of the time I'm scratching my head and saying, I should have become a lawyer. Because then it doesn't matter what I say, it works anyway. And if there's a problem, I just add text. Confuse people even more and they pay me more, right? But I think that we're going towards review, setting the boundaries, and deciding what's important. And then checking the AI that it listens to what you say, instead of doing necessarily. The paradox is still there. I don't know how to solve it. If you have an idea, send me an email. We'll become billionaires. So, where the research is. Big picture problem, lost in the middle, memory. That's a big problem. There's a bunch of stuff that's happening that's really cool. But in essence, I think when I talk to most lekmän, it's called in Swedish, so most non-nerds, right? They think you can train a model. No, you can't train a model. You give model input filling the context window. So a skill is filling in the context window. Context is filling this context window, and your prompt is filling the context window, and that costs money. So how do you do this? And how don't you rely on updating a model every 2 seconds? Well, it's impossible. So this is a problem we are having. You can look at it like this. You can try to force it into human behavior, or you can think about if you think about it like an employee. Let's say you employ a PhD student. How many here know PhD students? All of it? Some are PhD students, maybe? No? No PhD students here. No PhD students allowed. They might get ideas. Never good. So if you think about a PhD student, if you employ a PhD student that's a super genius but has a memory of 5 minutes, would you teach them and supervise them in the same way as a normal PhD student? No, you wouldn't. Think about AI like that. Can we extend the memory? That's one strategy, right? Make the memory longer. Or do we have to change how we work and supervise to adapt and take advantage of the super genius within 5 minutes? Another thing is adversarial verification validation, which basically means you can literally use AI to check AI. You can use AI to check you. You can use AI to validate. Prompt and smell sensitivity, basically what you enter is decides to a large extent what comes out. And this is more luck-based today than anything else because we don't know that profession properly. A general tip I do is I have a smaller local model that I discuss things with, and it creates the prompts and the strategy for using enterprise models. So because it's too costly otherwise. I figured that out when my quota was like, you're 90% done. And I said, I need more quota. And I started clicking this, buy more, right? And then I looked at the bill the end of the month and said, this is not reasonable. Why? I wrote a research application, right? And I used like 7 quotas. Multi-agent requirements engineering, stuff is happening there, right? Mare, for example, really cool stuff. I think that's the way to go because you can divide responsibilities, you can divide tasks and be more specialized, which I really like. Then, of course, you have 2 of my favorites. One is Gen AI first requirements engineering. What I mean by that is we are now trying to use Gen AI in a way that we normally work and trying to superimpose Gen AI on our workflow and our way of thinking. Yes? Well, when I sum 2 things on a piece of paper, it's not the same as when I use a calculator, right? I use different ways. Why are we using the same way with Gen AI as we do when we work with humans? Maybe rethink it a little. For example, why not revive nano architectures? So you have really hard really hard coupling cohesion rules and have very small context windows. And orchestration, the APIs or the connections between the modules is orchestrated by AI, which scales, which it didn't with humans. You have a piece of software, normally 5 components, now you have 500 components. Nobody in the right mind would do that, but if it's automated, maybe. And then human in the loop. This is an important one. Human is the loop. What I mean by that is, let's just say now we're 10xing requirements engineering, right? So it's 10x, right? So we keep all the people, right? But we just 10x the productivity. So finally we can do requirements engineering properly, right? Because we do like by 10% of what we need to do, then we need to start coding, right? So what should we do if we're not doing use cases? We need to invent things that are important to do, not just busy work. But what's important in requirements engineering which we don't have time to do today or don't know how to do today or we don't do today? I would say that's one of the most important things. Because if we assume that the engineering becomes better and we figure out how to use Gen AI properly, right, and it's really working well, which it will, much better than today, then what will humans do? Well, there are 2 answers. Nothing, sitting on a beach and then, using Telegram or Signal to send a message to your agent stack to do something for you. Yeah, you can have an agent doing that, so you're fired. Or we can think about what should we be doing as requirements engineering today, which we don't have time for, which create better products. I can invent a lot of things, right? You know, when you're doing requirements engineering, you're frustrated because time runs out. Why did it run out and what can you do? That's the cool thing. And I think that's important future research direction for us. What should we be doing if we're not? Then we have the other perspective. So we talked now mostly about AI for requirements engineering or AI for engineering, right? But the completely other perspective is, what if we engineer non-deterministic stuff? So just an example, excuse the ugly graphics, but if your software-intensive product or service, right, so pure software, car, doesn't really matter, but it's mostly software, contains an AI component, which you either built or bought, you need to actually adapt to that. So think about it like this. You basically have a normal thing. You have an application layer, you have a central layer, and you have a base layer, infrastructure layer. And part of this is model, right? And the model is either local, and you have memory and skills, and you have data, and then you have some sort of trusted supplier, right? And then you have enterprise models, right? This is the new stack. I won't go into details like security, trust, it's too big, right? That's like 10 hours discussion itself. But let's assume, you know, no evil actors, everything is trusted, everything works. Well, literally, either you have something locally running or you're completely in real time dependent on this chain. That's, you know, architecturally how it works, and that's fine, right? But we need, architecture needs new work. Also our patterns for good architecture is kind of, you know, not the same. Because the fundamental problem is not that. The fundamental problem is this is going to happen. Why? Well, we get learning systems. And I'm talking about the old-time learning systems, right? But I'm talking about creative systems. So you're using a booking site, right? And you tell the chat, I don't understand how to book a flight. And the chat asks you, how would you like to book the flight? And you tell the chatbot, well, I would like to figure out where the hell I'm going and compare the prices, blah, blah, blah. And it generates a new user interface for you, adapted for you in real time. That's the future of apps. Guaranteed. And that changes the game. Why? Well, you have literal coding and functionality being created in real time after deployment. How do you test that? How do you put requirements on it, by the way? How do you check compliance? This is a completely new field. We need completely new theories, new research. Then you can say, oh, we can't use that because it's non-deterministic, blah, blah, blah. No, but the competitor will, and you'll be out of business. Then you can use nothing being broke. It's as simple as that. This is happening. The question is how fast, and the question is what do we do about it? You have adapt to user, you have optimization, self-healing functionality, real-time systems, etc. So it's really interesting. Now, of course, some systems will have fallback positions, most systems probably, right? But you have the creativity of the Gen AI modules, which gives your system more usability, more user-friendliness, better systems that can solve more problems for the user. Of course, you want to leverage that, but at the same time, if you limit it, you end up with a deterministic system, which means it's meaningless and you're paying for nothing. That trade-off is really interesting and important and needs a lot of research. And if we go the one way, let's say it's a completely flexible system that is very adaptive, how do we do everything we do engineering-wise? And do we move the whole engineering automated to operations? Or is it, you know, a clean pipe that never ends in development? I don't know. Does it ever end? Because it's updated all the time. Why should the system have end of life? I don't know. But it's kind of cool. I'm really happy I have something to do until I go to pension. Every other day, I'm so happy to be alive, right? Every other day, I only have 15 more years. Then I can go, and it's not my problem anymore. But the cool thing is, how do we do stuff in this environment? And, well, I think a couple of ideas, right, which I think are important. I think we go from shall to should. So if the traditional is if a condition then, right? Well, I think this doesn't really work if you have a Gen AI module, but rather you need a probabilistic requirement specification, right? So, for example, for the example we have, well, if you arrive in less than 15 minutes for life critical, should be across 98% of the cases. So what that gives is a boundary that the actual generation or the decisions by the Gen AI module should adhere to. If you say medical devices, medical stuff should always be delivered, end of discussion, as fast as humanly possible. The AI can optimize that, so it optimizes fuel and everything else and then focuses on delivery speed, right? It might also run over people to get there. And then you say, oh, we can't have that. No, but it might come up with smarter traffic patterns than you do, right? Programmatically, and actually have better performance as a system. You should probably have don't kill people somewhere, but you know what I mean? So we're moving from traditional to a more probabilistic way of looking at things. And what that really means is you don't specify a path, you specify a statistical corridor with tripwires, right? So basically you have some sort of acceptance. This is kind of the golden rule. And then you have kind of tripwires where you shouldn't go over, and if you do, you fail over to a deterministic safe system, for example. You already have that in some systems, right? Like limp home, like auto-driving functionality, right? But it's add-on as a function based on a function that actually works. But here, the function is generated in real time, maybe, or the functionality is generated, or the quality is generated in real time, which means you need to lock it in much harder. But the lock-in is not programmatically, it is goal-based. And that is kind of important, that engineers need to be better at figuring out what the purpose of the system is and what's important. And requirements engineer need to be better at actual engineering and mathematics. So my view is that human engineer define the boundaries and the variance, and the boundary becomes a corridor where the system can operate. Then you can still have flexibility and utilize Gen AI in a smart way. And you also don't end up in a situation where it falls over. The problem is this won't work all the time. Because it's generative, it's probably going to generate stuff you didn't predict. That's scary, and we need research into this. I don't know how to solve it. Well, non-functional requirements becomes more than just talking about it. So how is a normal system devised? Well, you start with functional specification and then you run out of time. Then you have, oh, the non-functional is important. Yeah, look at the last system and copy-paste. Do we test it? Not really. Well, we test some things. What do you test? Okay, does it fail over during a backup? Yes. Done. Do you actually test if the user can use it to solve a problem in operation? No, not really. You test if it has a green button, and you're assuming the green button does what it should. But you don't actually test if the actual operator, 1 year after deployment, actually does a better job with the system. That's actually non-functional. Because that's the whole point of the system. How do I know this? I do a lot of post-mortems for government jobs. You know, big government agencies buying $1 billion worth of system, get it delivered and it doesn't work at all, and it makes life harder for everybody, including the customers and the indirect customers. But they paid $1 billion. And then they redo it for twice the cost, half the good. Yes. Because they don't actually test the purpose of the system. Purpose of a system is to achieve something, optimize something, improve something. We can actually start doing that with Gen AI. Why? Because we're not writing use cases anymore. That's what we can focus on. All non-functional aspects. That's kind of cool. But I would say the most important the most important thing we could actually focus on and do more is actual usability. And usability is not touchy-feely, do I like it? Usability is very specified. It's specified, 30, 40 years ago? Efficiency, effectiveness, learnability, etc. These are really concrete stuff that's measurable, but they're measurable in operations at the user's end. That's where I think verification, validation, and requirements engineering should be. Because that's not something that AI can do. It can collect the metrics, right, and help you do it, but actually figuring out what's important and what the system should be used for, that's the human domain. That's a huge area we can actually work more on and actually create better systems for the actual users. Then you have basically verification steps and requirements engineering generally doesn't end. That's also kind of important because you can't fully verify non-deterministic system at the release gate, which means it has to carry over after the release, which means we end up in a situation where you have different types of degradation in the system, right? The silent degradation, so for example, you change something inadvertently, right? Like a pre-prompting context, like the model is updated, something changes which has a huge impact on the actual system in operations. Remember, we have a Gen AI component in the system that's maybe 10% of the system, but it does stuff that the rest of the system is dependent on, and then it's in operations a year later, and the base infrastructure falls apart. The company you're buying the LLM from goes bankrupt, was bought by another company, it's a small update, small change, boom. This is not something we're that used to, really. We are to some extent, if you look at the cloud provisioning and stuff like that, but that's very on-offish in comparison to this. This is more subtle. It can be small degradations you don't notice. Like you have a diagnostics engine for MRIs, and it has 99% efficiency, right? Much better than most technicians, yeah? And then it's 98. Then it's 95. How do you catch that? You do tests, oh, no, you can't. Too expensive. So what do you do? Well, there are different strategies, but that's something we need to figure out. Performance envelope, autonomy paradox. Yeah, I mean, the more freedom we give Gen AI, the more capacity it has to do good stuff, but the more danger it presents. And the human role, well, we need to figure out how to set tripwires and failovers really well. We will become the core architects and the orchestrators of systems that have a life of their own, if you will. And when I say non-deterministic, I don't mean actual non-deterministic because it's technically not non-deterministic, but it's acting as non-deterministic, which means in practical sense it is. Yes. Research challenges. Are you bored yet? Okay, good. Nobody's sleeping yet. Good. Well, there are a bunch of research challenges here. Some of my favorites, but I think all are important. These are just examples. But for example, I think drift is really important. So the relationship between the model and the data is really important. So think about data. If you have a Gen AI component in the system, it's the data it uses is literally like code for the Gen AI component. Which means that if the data, and it's not as well formed as actual code, which means it's almost impossible to figure out if it's good or bad. But if it's bad, it degrades the output of the Gen AI component, which degrades the system. If it's good, the other way. Which means we need to make sure that data handling becomes a completely new discipline. Much more than it is today. For requirements engineers, that means data requirements, right? But not only data requirements by saying, okay, this is the type of data the system handles and it's GDP, blah, blah, blah. No. What's good data and what's bad data? That's a new topic and a new area and new knowledge that needs to be applied because it's context dependent, it's domain dependent, etc. What's good enough? What are the boundaries of the data? And this is a new field that's really interesting, I think. Because that data is not just input. Traceability of emergent behavior is also really interesting because unplanned is not necessarily bad or good. Unplanned is just creative. That's the point of Gen AI components. The question is, how do you catch the bad stuff without limiting it to only doing nothing? I don't know. How do you certify non-deterministic stuff? I have a couple of slides on legal stuff later. Only 2. That's how much I think we should give attention to legal stuff. Requirements monitoring at runtime. Not system monitoring, requirements monitoring. do we attain the goals and do we maintain the goal attainment after operations? Which means I think requirements engineer is not going to be something happening in the beginning and then it's handed over to a team. I think requirements engineer is going to be like an eternal product manager for requirements and goals and limits forever in all systems. So I actually think the role is going to increase if we choose to take that responsibility. I read a paper, I don't want to misquote anybody. I read a paper that most machine learning systems and or Gen AI embedded system in normal software, their requirements are done by machine learning people. I don't remember who wrote it. It's a really good paper. I'll put the link in when I send it out. That's really bad. Requirements engineering is kind of hard. I'm not good at it at all because I'm an engineer. I'm not good at it. I know very few people who are good at requirements engineering. It's a really important field. I'm not talking about requirements engineering research. I'm talking about actually doing it for real. It's a really hard discipline. And I know one thing, I'm bad at it, and I'm kind of a nerd, right? So nerd is probably not the best idea, to be honest. Then we need to require the model itself. What I mean by that is you need to put requirements on the actual LLM. But both for compliance sake, but also performance-wise. And can you freeze it? Well, if it's an enterprise model, how do you freeze it? How do you control that? I don't know. But data feeds behavior, model produces behavior, drift changes behavior over time, explanation makes behavior inspectable by humans, and runtime evidence tells us what behavior remains and what has changed. And I think this is a way to look at how requirements engineer need to preemptively think about this, but it needs to be done over the entire chain with multiple roles. I'm nearing the end now, I promise. Listen, I really like stuff in relation to compliance because I think the idea is good. So I like the fact that you have USB-C on everything, right? And not, what was it, speed wire, fire wire, whatever, blah, blah, blah. No, we should have one connector and not, fine. But I also don't like that I have to kind of figure out how to drink from a bottle again. So this is my friend says this. The US and China do, Europe regulates. And we can joke about this, but it's kind of serious, right? Which models are you using? Well, you're using Chinese or American models. You can use some local models, right? Some Europeans, but they're not as good, are they? Why aren't they as good? Are their engineers better than ours? Probably. They're more, right? They're more people. Yes? Chinese, I think I read somewhere that Beijing Institute of Technology examines or spits out 2,500 software engineers per year, or something like that. I don't know, it's true, but ridiculous numbers. And we're like, that's like Sweden. not our Sweden. So of course they're good engineers, right? But is it only that? No. It's electricity, it is GPU power, and it's data use. Do you really think that the big companies follow GDPR, data, blah, 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 blah? No. Sorry, you want to be competitive? Use all the data. We don't do that, we can't compete. Doesn't matter how much money we throw at it. But then I also think about this instead. When the internet came, is somebody that old here? I am. A couple of people maybe, right? You remember the internet, right? No, not when it came. It came overnight, but when it started, right? Yeah. Did we in Poland or in Sweden say, oh no, this is shit, we're going to invent our own internet, that's better? No, we didn't, right? We said, oh, this is really cool. How can we build stuff for it? Yes? That's what we did, yeah? That's how we need to think about Gen AI. I don't really care, to be honest, if American companies have it. I don't like that it's 5-6 companies. That's a problem. Why? Because the political or social or whatever convincing of the czars in those companies gives a direction of the answers I get from it, which is really dangerous. It's like 5 people controlling history or 5 people controlling not good. I don't care if they're good actors because they might be replaced by bad actors, right? I want everybody to have access to everything and all voices to be heard, and then we hit the stupid people on the head with arguments. That's my view. The same for AI. It's really dangerous with 5 companies. But I don't think that every nation, every university, every region, every nation, every region, EU, US, etc., everybody can't have all the models and the best models. This doesn't work like that. We already have the same. I use Mac. It's American Chinese, right? Yeah. I use an iPhone. Same thing. I don't use... Are there any European brands? Samsung is Korean, right? Google is everyone. So, what's the difference? Ericsson is... But you get what I mean? I wouldn't be too blind to this. But I think the politicians and the bureaucrats are, no, we need to invest in AI. They have no clue what they're talking about, first of all. They don't. I literally had a meeting with a politician, and my job was to have a 1-hour session what AI is and why it's important. And the person entered the room saying, this AI stuff. And I'm like, what the hell does he mean? What's I? And he's like, AI? And I'm like, AI. Okay, this is a policymaker. My point being, we need to be careful here. I absolutely think we should have more companies competing better, right? And they can also compete by quality, can also compete by freedom, truth, level of manipulation, right? So you choose the better model, right? You choose X over Y because it's actually more open and transparent, right? 100%. But you cannot legislate this. You can't use model X from the US because it's Trumpian, I don't care what it is, or Bidenish, or I don't care, right? That's the EU law. Yeah, and European companies are like, we're moving to China now, because otherwise we can't compete. We have to be realists about this. We have to allow use, but in a smart way. So the application layer is where the action is and where we need to focus. We need to be better at competing. Sweden was really good at the internet. Why? Because we invested a lot in the basic infrastructure, giving everybody access to the internet very early. That created what? Spotify, Roblox, sorry, not Roblox, Minecraft, right? Wouldn't it be impossible without that core functionality, that core idea, that core technology being accessible by normal people every day? That's how we need to think about Gen AI. And first, of course, companies, because they need to make money to pay taxes, to pay for everything else, and then people. The question is how we do it in a smart way without having a flavor. And this is how I see it, basically, regulations. It's not only over-regulation. Over-regulation is a problem, right? Because you mean well, but you end up in a situation where you need to have 16 lawyers to go to the bathroom. And the problem with that, it kills creativity, and I said, I don't have the energy. Have you ever been there? I have been there. Just the terms of service, I started a new startup, the terms of service normally takes me 5,000 to 10,000 euros for a lawyer firm to write like 4 pages nobody will ever read. It's so stupid, it baffles me. But I actually use OpenAI to actually write my terms of agreement this time for like $4. And then I sent it to the lawyers and said, review. And they came back, we don't do that. And I'm like, then I go to another firm and they're okay. And they billed me 400 euros for reviewing it. And they said, it's good. And I'm like, ha ha. So I love Gen AI. That's a good use case. It speaks really good lawyer. And it out-lawyers the lawyers. It's so good. I got the contract the other day where there was a IPR clause, we own everything, blah, 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 right? And I put it into Anthropic. I'm not doing commercial for Anthropic, just the model I was using. And I said, out-lawyer the lawyers. That was my prompt. And it created 4 new pages. And I just sent it away, and they were like, we'll get back to you. And then they got back to me and said, yeah, maybe we don't need all the clauses. And I'm like, no, let's remove some. So funny. No, but jokes aside, overregulation is one thing, right? I can't do much about that. We should really think about it, right, and not overregulate and not lose the intention of regulation. But requirements engineering and requirements engineers have a really important role here, because you can see it as requirements engineering owns it, right? So compliance as engineering. So basically, we have traceable and verifiable requirements that are compliant. But the outcome and operational compliance is the focus, not paperwork. So the intention of a law, which is translated into regulations, which is then translated into interpretations and standards, it's not creating 9,000 pages of documents to show somebody. That's the business side of regulation. The lawyers, the reviewers, all of these, right? They are literally, the really good ones are good, but there are also a lot of parasites in this environment that live on more is better, and right? And they bill. They don't care about that it takes twice as long to release a product, because we have CI/CD pipes that are blisteringly fast, and then it ends up in lawyers' hands that take 6 months before we can release. Come on. And then we're competing with companies abroad which release immediately. Now, is regulations bad? No. It's like nuclear power. It's really good if used correctly. It's really bad if you use it incorrectly. My point being, if we own it, requirements engineers, instead of producing huge amount of legal text and disconnected artifacts, right? You know what I mean? We actually own it, and actually in the requirements engineering phase, actually think about boundaries, tripwires, and metrics to figure out, does this system perform well? And then use that, because we need that anyway, right? We need that for the engineering of the system and for prompting AI and for the engineers, right? Why not reuse those requirements, because they need to be very specific now. It can't be, needs to be feel good. No, here's the tripwire, here's the probability kind of thing, right? Good. Use that as legal documentation automatically, and then use Gen AI to translate it to lawyer. All of a sudden, we can actually do regulations, even if it's over-regulated, but much faster. And this is, I think, the future of, and I think this is a huge research area we need to focus much more on. And actual engineering people need to focus on this. We cannot leave this to actual social scientists and lawyers only. Because if it does, the abstraction level is going to be so big, the gap between what we are actually doing versus what's actually regulated and how it's written is going to be so large that you can squeeze an elephant or an aircraft carrier in it. And that per definition kills all things. But why? Well, if I'm a manager and I get the question, are you compliant? I'm going to say, I don't know, because I don't want to be hanged, right? Then I escalate it to my manager, and my manager says, I don't know, I'm not going to be hanged. And then it comes up, right, 4 levels, and then 900 lawyers are set on the case. 6 months later, nothing is generated except 9 million pages of documents, right? And a huge amounts of meetings, and we're compliant, process compliant. Yes, we did everything. We had meetings, we talked about it, we did this, and complete rubbish because the system can fail anyway. Nobody actually tested if the system is compliant. Hello? And you cannot write the requirement, be compliant. So how do you write the compliance requirement? Well, of course, there's research on this, and they're good at it. I'm not saying that. What I am saying is, with the advent of Gen AI in systems, so non-deterministic components, this is changing the game completely, because you can never assure compliance by functionality at release date. So we need to use the actual new ways of working with Gen AI and Gen AI components as a way to become compliant also. And that's the key. So I'm almost done. So you can see Gen AI on both sides. You can both use Gen AI, and you can requirements engineer for Gen AI, but you can also use Gen AI to do compliance work, which I think is really interesting. So basically, to summarize, I think requirements for AI and AI for requirements all feed into requirements engineering as a field. And I think every engineering field, at least every main process area in my field, software engineering, is up for radical change, even if the models don't evolve anymore, because utilization is very low. And the winners is going to be those who leverage the new technology as much as humanly possible while maintaining the quality aspects. So I think quality, all of the things I talk about, tripwires, probability, all of these are quality assurance on the functionality, right? So I think quality assurance, non-functional aspects, quality aspects is going to be the new gold in requirements engineering. Because you literally feed non-functional requirements to a operational programmer that adapts functionality. You don't feed it to developers who interpret it and then devise a function that then tests it. It's a different thing. The tester is live. Which means that I would say, if you look at it like this, maybe 80-90% of research in requirements engineering is about functional stuff, and say 10-15-20% is on non-functional stuff. I think that's going to flip. That's my prediction. If we choose to. Good. Thank you very much. Oh, and I would like to thank the Institute of Computing and the university, but especially I would like to thank Sylvia for putting up with me. Did you survive? Good.
So thank you very much for your talk. And just to, still we have some time, so are there any questions? Would you like to discuss some issues still when we have Professor here?
Sorry. Okay, thank you very much for this incredible talk. I have lots of questions, but the one I would like to focus on is it relates to your experience with these companies. So when you generate lots of requirements, and of course this also is about the fact that, as you said, that normally these systems, they don't have memory, and you have to have some kind of memory. So what you're ending up very often is you have multiple layers of requirements, just so the LLMs and agents, they understand what they're doing and something remains afterwards. Mm-hmm. And at some point, as a human being, as you said, you become a bottleneck because you don't comprehend anything like what's going on inside. So unless you're Ericsson and you have an army of analysts, you have to somehow cope with that. Yep. To understand. So do you know any techniques, methods that people in industry are using nowadays to somehow comprehend this complexity?
The short answer is no. No, I'm just being honest about it. Most application in industry today is technical. So I've seen very few instances where, except trivial use, it's actually used for requirements engineering. Oh, it's absolutely coming, but it's been very limited because the easiest way has been for programmers to generate code. That's basically where everything started. Now it's seeping out, right? So it's going to database administration, right? To look at pull requests, stuff like that, automate that part, because that's generally a narrow sector. It's also going towards verification validation significantly, right? Using AI to create artifacts, but also to test. It's also spilling over to product management, market analysis, that kind of thing, customer analysis. Data, using huge amounts of, normally you have huge amounts of data, which is very messy and a big pile of heterogeneous data, which you couldn't do anything with machine learning before cleaning it. You can kind of use it now, right? So requirements engineering is piping in here. But what you're describing to kind of generate large amounts of requirements, I think most applications today jump immediately into architecture, design, and development. And requirements engineer is actually taking a secondary role, and things are actually moving really fast in engineering and production and release without the requirements engineers. They're actually behind the ball now. And it doesn't notice much now because you have established products and you have evolution of features, right? Or adding a small feature, which is mostly one-liner. You add the green button. I know what you mean. Then you add it, right? But it's really dangerous when you're designing new systems, new ways of working, redesigning systems, where requirements engineering is critical, right? I actually think there's going to be a gap there. The engineering part, if you call it like that, like the implementation part, is going to run much faster, and the requirements engineering is going to try to catch up. There is research going on. I'm not saying nobody does it. My experience is mostly engineering layer is using it now. The thing I've seen about requirements engineering is that they generally write requirements and automate use cases, but then they generate something that's humanly visible, like, for example, an interaction diagram or UML diagrams or something like that, and they review that. And that's a big problem, right? Because you have a huge abstraction between the two, and also intent is missing. One positive thing I've seen is that people actually start using GQM or goal stuff, because now you can auto-generate the metrics, right? Which was easy before too, if you know the domain, but nobody did it. Now it's automated, so it's very fast. So they're actually starting to using that, but I haven't seen really well if they connect the metrics to actual test cases and operational orders for the systems. That pipe is, I think, to come. There's probably people online screaming their heads off, we're doing that, fine, but most companies aren't. And they're kind of working a little here, a little here. I think the most integrated is engineering part, the coding and the testing. That's kind of really integrated in terms of Gen AI usage, right? More. But even there, they're exploring. I mean, it happened a couple of years ago. Sorry for not being able to give you a good answer.
Okay, any other questions? So I will add one more about creativity. So right now, Google has announced that the skill of the future people and the skill that we should all master is the creativity. How do you feel about this? And how do you feel about, like, if you say about the models, are they creative enough? Maybe they would be more creative still than we are.
Oh, that's a difficult question. So I would say Google is trying to justify replacing people with AI. That's my, gut feeling. Here's the interesting thing. I think we're doing the same stupid thing we did with outsourcing. You remember outsourcing? Right? Well, let's put everything in India or wherever, right? Because it's cheaper. Then I realized, oh shit, it's not cheaper. Because they not that they're not good engineers in India. That's not the point. The point is they don't belong to your company. They move around a lot. They don't understand the domain the same way. So more defects, blah, 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 right? Not like moving from India to Sweden with the same thing. So they figured out that outsourcing doesn't work. So they insourced it for twice the cost again, lost a huge amount of money, but somebody got paid somewhere. And now they have companies in India with access to good engineers, right? But they're owned by the companies more or less that work with them, right? I think we're in the same process with Gen AI. The first reaction by managers, and when I say manager, I mean the people who are not actually doing anything, but doing Excel, is, oh, we can save money. But they realize token cost is escalating a lot, right? And so we need somebody to check the stuff, so we need engineers. We don't need entry-level engineers. I heard that. And I'm like, how do you get senior engineers if you don't have entry ones? They're like, we didn't think of that. And I'm like, oh, Jesus, tell me it's not a professional operation. So I think we're going to make the mistake of trying to get rid of people to replace with Gen AI. We're going to realize that doesn't work. We need more engineers, and we need to 10x productivity given relative engineers. That's where I think we're headed. We should head. And I think the successful companies won't scale down. They will scale down stupid stuff, but they won't scale down the core business. They will actually increase that, but they will say you increase it to 10% number of engineers, but you 10x productivity. All of a sudden, you're actually downscaling the cost indirectly, right? I think that's where we're going. I think rule setters, people who understand how to think logically to set the boundaries of a system, are going to be king in all layers. And I think people with good ideas are always going to be king. Because I don't think Gen AI can create a really nice image, better than I can, but it's kind of soulless. Have you noticed? I do a lot of Gen AI generation of images. Why? Because it's fast and it's cool, and I like it. And it does a good job, but it's soulless. And we people are the users of the systems, right? So we need soul. And I think humans are needed for the soul. I think that's always going to be true. Unless we get general artificial intelligence, but then we have other problems. But I don't think, I also don't think it's fair to say everybody should be creative now. That's like saying everybody should be a mathematician. most people can't be a mathematician because they're literally not built like that. I don't care how hard you work at it, you'll never be a mathematician. I'm one. I tried, didn't go well. My mathematics professor told me, maybe you should become an engineer instead. You're kind of good, but you're struggling. And I'm like, oh, thank you. But for real, so I think that creativity is important, but I think that humans need to be the creative part. I think speed of creativity is going to explode because you can try stuff out for free comparison. I had an idea for an app. Normally it takes me 2 weeks to cobble something together that kind of works to see if it works, and I show it to people and they say, oh, this is really cool. No, it's not, right? But now it takes an hour and I can try out 10 ideas at the same time, right? That's the power, I think. But I don't think most people will be creative because most people are not. And I don't think people are going to get fired because they're needed. But I do think what we do is going to change radically. I mean, my profession as a software engineer, I wouldn't be hireable today without Gen AI knowledge and how to leverage that. I'm not hireable. Doesn't matter how good at you're a programmer. Doesn't matter. In 10 years, you're either knowledgeable about this or you're not. And then you have to be creative, but you can be creative in the boundary setting of the orders you give the automation. So figuring out where the fall points are, where are the limits the system should be able to do stuff, right? That's super important. And you need to think 3, 4, 5 steps ahead because the system is going to try to adapt to go around the rules. It has the mission of going from A to B, right? And you put limits on that. Don't run people over. That's a limit, right? Then it figure out, what about animals? Can I run them over? Yeah, but you didn't say animals. Right? Oh, shit. That's going to happen. The really good people are going to be the ones who can creatively foresee and put the boundaries in. And that's a really important type of creativity. We don't really categorize that creativity. It's not just math or knowledge, it's also creativity. I think that's where human can excel. Sorry for being long-winded.
Thank you very much for answering the question. Any other? No, so thank you very much one more time.
Thank you.
So here is thank you from us and from the public. Now I would like to read the thank you letter from our major of city. So, dear Professor Gorschek, I'm extremely pleased and honored that you have accepted the invitation of Poznań University of Technology. The visit of such an eminent expert in the field of software engineering is a great privilege for our city. In Poznań, we strongly support the academic society through various initiatives. We encourage academic exchange by providing students, scholars, and researchers with opportunities to meet renowned and distinguished scholars and artists from all over the world. I'm deeply thankful that you agreed to deliver an open lecture on your academic interest to our academic community, and I'm convinced that this will be highly appreciated by both the academic audience and our citizens. I believe that your visit will contribute to a fruitful cooperation in the future. Jacek Jaśkowiak. So thank you very much. So
thank you.
Our member, thank you very much.
Thank you very much.
Okay, and then the second thank you on behalf of our rector of Poznań University of Technology, a small souvenir from our university. So thank you very much.
Thank you.
And one more thing. So this is from our team and from the conference that you were also visiting. So it's a kind of bottle to store warm drinks.
Oh.
So we hope that you will warmly remind us in the future when you will drink your drinks.
Thank
So
you very much.
Thank you very much.
Thank you.
And thank you all for listening to the lecture, and see you in the future.
Too many nice words. Thank you. Thanks a lot, everybody. I hope I didn't bore you too much. One thing, I'm doing a short visit. I have a lot of deadlines, but me and Chris are coming, planning a trip in autumn, where we would like to come, if it works for you, to discuss actual research and stuff. That would be cool, right? So if we can find a date, we'll come and we'll exchange ideas and see if we can do some stuff together.
Okay. Thank you very much.
Thank you.